Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on independent and mutually exclusive events. So we're going to be looking at calculating the probability of events that are independent or mutually exclusive. There are special ways to do this. So let's look at the definitions. So two events A and B are said to be independent if one does not affect the other. So if they're independent, it turns out the probability of A and B, the probability that both events happen is just the product of their respective probabilities. To find the probability they both happen, you just multiply together their respective probabilities. So two events A and B are said to be mutually exclusive if they can't both happen at the same time. So in that case, what that means is that the probability of A and B is equal to 0. It cannot be the case that both events happen. So we're going to use these rules in our calculations. So let's start by looking at an example involving independent events. So let's say I toss 5 coins. What's the probability that I get all 5 heads? So if I toss a coin over and over, each time I toss it is independent of the previous. If I toss heads this time, that does not affect the chances of me getting heads or tails next time. Each time I toss the coin, I have a 50-50 chance. I have a 1/2 probability of getting heads and a 1/2 probability of getting tails. So the probability that I get heads 5 times in a row, so there's a 1/2 on the first go, 1/2 on the second, 1/2 on the third, 1/2 on the fourth, and 1/2 on the fifth go that I get heads. Because they're all independent, all I need to do is multiply their probabilities together. So that would just be 1/32. So please make sure this rule here only works if the events are independent. If the events are not independent, we don't have an easy way, we don't have a formula to figure out the probability that they both happen or that they all happen. So let's look at another example involving independence. Let's look at this question here. A multiple choice test contains 3 questions. Each question has 4 possible options. And I want to figure out the probability that I get at least one question right if I randomly guess each question. So this one's a little more tricky because there's a few possibilities. I could get the first question right or the second question right or whatever. I also could get one question right. That's at least one question. If I get 2 right, that's at least one. And if I get all 3 right, that's at least one. So sometimes it's easier to use our rule for complementary events. So the probability I get at least one question right is 1 minus the probability that I answer 0 questions correctly. So that's what I mean by P0, that I answer no questions correctly. So let's figure out the probability I answer no questions correctly. Well, each time I take a question, I have a 3 out of 4 chance of answering it wrong because there's only one correct option in multiple choice. So that means the probability that I answer each question wrong is 3/4. So the probability I answer 3 questions in a row wrong, so each one's 3/4, but I can just times them together because the events are independent. Because if I randomly guess the answer to the first question, it doesn't affect my chances of getting the second question right. If I randomly guess each question, it doesn't matter what happened on previous questions, my chance of getting it wrong each time is the same, 3/4. So I can just simply put that on my calculator and I get 37/64. That's the probability that I will get at least one question correct. So that question, the answer to this question, would not have been possible were it not for knowing about independent events. I couldn't have known that the probability of getting 0 questions right was just this expression here. I couldn't have known that without this rule here. But remember, it only works for independent events. So let's look at some questions now involving events that are mutually exclusive. So we looked at independent events, which are usually questions involving and. It turns out mutually exclusive, we're usually dealing with events involving or kind of questions. So it turns out the probability of A or B, to find that, you just add the two probabilities and then you subtract the probability that they both happen. That's pretty commonsensical. That is true whether or not A and B are mutually exclusive. But if A and B are mutually exclusive, this last term goes away. If A and B are mutually exclusive, to find the probability that either or both happens, you can just add together their respective probabilities. So let's look at an example of this. So let's say I randomly pick a card from a deck. What's the probability? It's either a picture card or a 4. So we have two events here. Picture card, which means king, queen, or jack, or a 4. These two events are mutually exclusive. They can't both happen at the same time. If you pick a card from a deck, it can't be a 4 and also a picture card. It can't be both. So the probability, I'm just going to write P for picture, P star for picture, or 4 is just the probability of getting a picture card plus the probability of getting a 4. So probability of getting a picture card, so there are 12 of those. There are 4 kings, 4 queens, 4 jacks out of the 52 in total. And the probability of picking a 4 is 4 over 52. So just together and you get 16 over 52 or 4 over 13. So that's the answer. How easy is that? So now we're just going to look quickly at an example where the events are not mutually exclusive. So please pause and copy this down if you need. So now I randomly pick a card from a deck and I'm going to find the probability that it's either an ace or hearts. So these events are not mutually exclusive. Ace, hearts, because you can get a card that is both an ace and a hearts at the same time. Of course, that happens if you pick the ace of hearts. So we can still use this OR rule, this addition rule. It's just that now we're going to have to include the probability they both happen. So the probability I'm going to call A for ace or H for hearts. You find the probability of each and add them together, and then you have to subtract the probability that both of them happen. So the probability of getting an ace is 4 out of 52 because there are 4 aces out of the 52 in the deck. The probability of getting a heart is 1 over 4 because there are 4 suits. Hearts, diamonds, clubs, and spades. Now, the probability of getting a card that is both ace and hearts is 1 over 52, because that's the probability you get the ace of hearts. There's one such card in the deck out of 52. So now you simply put this in your calculator, and you get the same answer as last time, 16 over 52, or 4 over 13. Okay, and that's the final answer. So thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.